Hello, it's Keith here, and this is lesson 2 of the platform-specific series of my 6809 assembly programming tutorials. This time we're going to be looking at the FM7, the Japanese machine, and we're going to be looking at how to read in keys and how to read in the joystick, which is going to be quite interesting. Let's go over to today's example and we'll see it in action. Okay, so here's the example code. If I just fire this up here, unfortunately the screen flickers a little bit because of the way I'm reading the screen and working with it. If I press a key on the keyboard, for example if I press A here, you can see the ASCII here is 61, B is 73. If we just go 1, 2, 3, you can see 31, 32, 33 here. If I press space we get 20, if I press enter we get character 13 here. So we're reading in actually ASCII here. We're using a single byte here, but the keyboard does actually have an 8th bit. There's a sort of 9th bit in a separate register, and this is used by the function keys here. So F1, F2, F3 here are marked as 103 here. So that's what we're reading in now. The reason we're reading in ASCII values here is that the FM7, to my knowledge, doesn't have a keyboard matrix that we can directly read in, so we can only read the ASCII keys, and we'll go into how we're doing that here in just a moment. Now we're also reading in the joystick. You can see at the top here, if I press up, down, left, right and fire, that's joystick 1 here. There we go, there's the first fire and there's the second fire. So that's joystick 1. We have a joystick 2 at the top here. Now you can see here that actually when we're reading in the keys, the value of the key press that we read in is the last key pressed, even if the key has subsequently been released. Now that's not very helpful in a lot of cases, but what we can do, if you look at the bottom here, if I hold down space here, you can see 20. If I let go of space, it goes back to 0. And we're using interrupt handler to do that. So that's the example we're doing today. We're going to go over all of that and we're going to learn how it works. Let's just go over to our theory here and we'll just discuss a little bit more. So bits 0 to 7 of the key that's read in are stored in one port, and the 8th bit is stored in a separate port. Now reading the keyboard is a little bit odd because on the FM7 there are actually two 6809 processors. There's the main one which runs our program, and there's the sub one which handles the sub devices like the graphics. And yet I would have kind of thought that the sub one would be the one handling the keyboard, and it can, but it doesn't have to. The output for the keyboard device is actually piped to both of the CPUs, albeit at different ports. So from our main CPU that's running our program, we can read FD01 to get to the ASCII key, and the 8th bit, the extra bit, if we're used by the function keys, is in FD00. Now, if we're using the sub CPU, which we're not, and it's very difficult to, but if we were, that same data would be available from D400 and D401. So there we go. Now if we just need to read the last key that was pressed for some reason, then we can just read those in straight away. However, that's going to be a bit problematic because if we're making some kind of game and we want, to hold down space to fire, we're not going to be able to tell when space was released. So we're going to actually have to create an interrupt handler to handle the keyboard interrupt, and then when a key is pressed, that interrupt will fire and we'll store the values from that. Okay, let's have a look at our code then. So here is the code where we're reading in the ASCII values. We're reading in FD00 here, and then we're reading in FD01 here. Now there is just one bit of FD00, so we're reading that in, and we're actually shifting it to be the top bit of these 2-byte pair here. FD01 is the basic ASCII value, so if you want your A to Z, your 0 to 9 and things, that's what you'd read from. But if you want those function keys, you need FD00 as well. So this is reading in directly, and as I say, the key could have been pressed 10 minutes ago, and if no keys have been subsequently pressed, it's still going to be in that buffer, so that's not necessarily very useful. So what we're going to do is we're going to create an interrupt handler. Here's our interrupt handler here. And what we're doing, and having read up the documentation better, I now know you don't need to push and pull D there. And it's actually, the registers are actually backed up automatically with this interrupt handler. I didn't realize that when I was writing this originally. So basically, all we're doing here is we're reading in from that same port, but this interrupt is going to be fired when a key is pressed. We're going to configure it to do that. How do we configure it to do that? Well, we need to set the devices that cause an interrupt, and so here are the options. We can have a timer, a printer or a keyboard, or the RS232. We're just selecting keyboard here. This bottom bit here selects keyboard on, and we write that to FD02. That turns on the IRQ for the keyboard. Okay, and that will mean that our interrupt handler will be fired. Now the interrupt handler is defined by memory address FFF8 here. That's the vector that the 6809 uses. So we load the address of our interrupt handler code and then we just store it at that address. And then once we turn on the interrupt handler here, that will cause that interrupt to fire. And that means our interrupt handler will run and we'll be able to process our interrupt. So that's how we're reading it in. What we're doing then is we're just loading in from FD01 and we're storing into a temporary byte here. And we are just going to then read that in, show it to the screen and zero it. And the effect of that is that if the key is pressed down, it shows, and if the key is released, it goes back to 0. So that's what we're doing there for the keyboard. Keyboard is relatively straightforward. It's just a bit annoying that the buffers don't clear themselves, and unfortunately we don't seem to be able to write a 0 back to them to clear them either, so we do have to use that interrupt handler. Now, what about the joystick on the FM7? Well, the FM7 doesn't have a joystick, and you're probably thinking I've gone mad there because I said it did have one before. Well, it doesn't by default have a joystick. What happened is later they made an upgrade card for an FM synthesizer. The FM7 didn't have a FM synthesizer despite the title, and that FM7, it actually had the AY chip built into it, and the FM7 already had an AY chip, but the data ports on that AY chip actually connect to joystick ports. So with that FM7 add-on card, we can then support a joystick. So what we need to do with that FM7 card is select those ports on the AY emulation within it, and then we can actually work with the joysticks that can be connected. Now, to send a command to a register, we need to send a sequence. We send a register number to port FD16. We then send a 3 to FD15, and we then send a 0 to FD15, and that will select the register number. To read in a value from the register, we need to send a 9 to FD15, load in from FD16, and then send a 0 to FD15. FD15 is basically the control port, and FD16 is basically the data port. Now, when we want to write a register, the function is basically the same. We store the register number to FD16, we write a 3 again, to FD15, we write a 0 to FD15, but this time we then store the value to FD16, and this time we then write a 2 to FD15, and finally we write another 0 to FD15. So we have to do this every time we want to read and write registers. A bit of a pain, but basically we can just use these for the FM registers. Now, as I say, we're using the AY emulation of the FM chip, but the commands and the ports would be different for the true AY sound chip that's built into the FM7. We'll look at that later in the sound tutorial. Now, how do we actually work with the joysticks? Well, what we have to do is we need to select the direction of the ports within that FM sound chip. So first of all, what we do is we turn off the joysticks. And to do that, we write 7F to port 15 here. We do that, that will turn off the joysticks. And then we're defining the directions of the bits of the ports. So basically, we want port 15 to be an input. So we put a 1 here. And basically what we want to do is to set port 15 to be an output, and set port 14 to be an input. Now, port 15, as you saw here, is basically the joystick select port, and port 14 is basically the data from that joystick. So this will set up our joystick here, and then what we need to do is we just need to read it in. Now, we've basically got two options. We can read in from joystick 1, the first joystick, by writing a hexadecimal 2F to port 15, and then we just read in port 14, and the format is very nice and organized. It's up, down, left, right, fire 1, fire 2. And to do joystick 2, we just write a 5F, and we read in again from port 14. So port 14 is the data port, and port 15 is the joystick select port, and of course we can write 7F to select no joystick if we need to do that for some reason. And as I said, we can see in my example here, this is joystick 1, so up, down, left, right, fire 1, fire 2, sorry, not familiar with my own joystick settings here. And then if I just go to the options for the joystick, if I can find them, and if I go to joystick here and I select joystick port 2, well, now my same joystick is controlling the joystick port 2 of the emulated machine. So as I say, we can read in the joystick relatively easily there. It's just a shame that the basic hardware didn't have one, but it didn't, so that's the way it is. Anyway, that's all we're covering today for the FM7. Fortunately, we got things working pretty quickly. We're going to be seeing again how to work with the AY sound chip in a later tutorial when we look at sound on the FM7. But As I say, for today, we're just going to stick to the keyboard and the joystick. Anyway, I hope you found this interesting. As always, you can go to my website and download the source code on this. I'm hoping people will find it interesting because I don't think there's a lot of documentation on the FM7 in English out there because I've had to read some in Japanese. But anyway, whatever you do, if you've liked this video, please like and subscribe. It helps my motivation to keep working on the videos because a video like this is 5-10 hours behind the scenes of work, preparing it, writing the documentation, reading the documentation and getting an example that works to the best of my ability. But whatever you do, I hope you have some fun with the FM7. Thanks for watching today and goodbye.